Hey guys, today I'm going to be showing you how to use the Star Tracker to get really high quality nightscapes. Today I'm going to be using the Ioptron Sky Tracker Pro. Now, if you want to learn more about this device, I already have a YouTube tutorial that covers everything in depth, so I'm not going to go too in detail. I want this to be more of a general Star Tracker tutorial. And we're going to start off just by the entire installation process, from aligning it to getting your composition looking good. Then we're going to attach the camera, go over some tips for that, setting the intervalometer, and hopefully by the end of this video you'll be more than comfortable to head out on your own and really take your Milky Way photos to the next level. Alright, so here we have the Star Tracker itself. Now if you get one of the Ioptron models, they come with their own base here, so you don't need a ball head. And I can just unscrew this and take the Star Tracker off by itself. And again, if you want, you can attach a tripod plate here, put this directly on your ball head. It's going to make alignment more difficult, though this is going to make things a bit easier for you, so I recommend just sticking with it. So anyway, I'll put that back in its slot there, tighten this down. And then all I want to do is just screw this right onto my tripod, so you might have to unscrew your ball head to do that first. Once I've got nice and tight on there, I've got two steps now. First, I need to make sure that the bubble level is showing me that we're flat. Being flat is very important. So if you can find a place where, like over there, we've got some pavement, but right now we're in the grass. So if you can, try and find a nice flat spot to begin with. Next, we need to make sure that we're actually pointing north. Now, when you're out at night, you want to find the Big Dipper. The Big Dipper is always going to be in the northern sky, and it's very easy to identify, even if you're in a light polluted sky. Once you've identified the Big Dipper, you're going to find the North Star. And the North Star is usually easiest found by drawing a line from the upper rightmost star in the Big Dipper and just tracing it straight out. And once you find the North Star, that's where you want to make sure that the Star Tracker is roughly aligned to at this stage. So I'm more or less facing north now. Let's just say the North Star is right up there. That's good. And again, I need to make sure the tripod's level. So the only way I can do that right now is to just adjust my tripod legs, and this is where it's kind of a little bit of a pain, but it looks about good there. Tighten everything down. And our next step is to adjust for the latitude and try and make sure we can see the North Star through our scope. Now, my recommended process for finding the latitude is to simply use the photographer's ephemeris. I've got it right here on my phone, and basically this is an application that I use for landscape photography and Milky Way photography. I can see things like what time twilight is, what time astronomical twilight is, and it just has a ton of great info. But again, the main thing we're looking for right now is the latitude. So I know I'm at 41 degrees north, so I can come over here to my Star Tracker, and what you want to do is, there's a lever here on the side. You need to loosen that up just by turning it, and once that's nice and loose, I can use this back dial to just rotate the Star Tracker backwards. And if you look close here on this side, you'll see that there's actually a couple numbers, and they correspond to your latitude. So again, we're at 41 degrees north, and I'm just going to keep cranking this back till I'm as close as I can get to 41, which looks right about there. Once I think I've got it good, I'm going to tighten this down. And now my Star Tracker should be pointing at the same altitude as the North Star. Once that's dialed in, I'm going to come behind the Star Tracker, and at this point you shouldn't have the polar scope in yet. What I like to do is actually just look through this hole, and when I look through there, I want to see the North Star somewhere inside of that hole. That's the easiest way to get your rough alignment set. And if you're using like a 14mm lens, you're not going to have to be super precise. As long as it's somewhere in there, you're probably going to get good tracking. If you're doing anything over 100mm though, you want to be spot on. So that's where you're going to attach your polar scope, and we're going to look at more of a detailed alignment next. Alright, so I've got the polar scope here. Again, if you have the Sky Tracker Pro, this will come with it. It's a really valuable tool. If you want to learn more about how the scope actually works, check out my in-depth tutorial. But right now, again, this is going to be more of a general overview. So what I want to do is just slot this into the hole here, and you want to make sure there's going to be a screw either on the side or on the bottom. You want to make sure that's loose, and then tighten it down so the scope doesn't come out. Once you've gotten the polar scope in there, now we can just crouch down again. You should see the reticule inside of the scope, and We're going to need another application right now to make sure we have a very precise alignment. So if you're on Android, it's called the Polar Finder app. On iPhones, I think it's actually iOptron's own app. Either way, consult your manual for the proper application, or I'll have a link in the description. And you want to open that up on your phone, and then we can know exactly where we need to put the North Star in the polar scope. Alright, so I've got the Polar Finder app open on my phone, and I'm seeing here exactly where I need to have the North Star at. So you don't actually always want it in the center of the alignment or reticule. You usually need to have it offset somewhere. So again, consult your app, see where you need the North Star to be at. Once you know where it's at, we need to get back to our star tracker, look through the scope, and normally provide your latitudes dialed in correctly and you've actually identified the North Star properly. The North Star is somewhere within the reticule, and there's two different ways that we're going to have to adjust it. First, I almost always have to adjust for the latitude. I'm always a little bit up or down. So again, I'll come over to the side here. I will loosen the lever, and then I'm just going to come back. I'm going to crouch down here, and I'm going to see the North Star, and I'm just going to slowly rotate this knob either up or down, and that's going to allow me to get very precise where the North Star is at according to the app. Once that's good, I'll lock this lever back down, and then my other step is to adjust either left or right, and that's where we're going to use these screws here on the star tracker base. And come around here. There's actually a screw on both sides, so we need to loosen both of these up first. Once these are both loose, now we're going to use these thumb screws to adjust either left or right. So you need to turn them both in the same direction, and as I do that, you'll see the star tracker very slowly turns left or right. And again, I'm going to be down here looking through here as I'm adjusting these, watching where the North Star goes, trying to get it pinpointed the same way as it's in the app. Once I've got it as close as I can get it to the exact same spot as I'm seeing it in the app, I want to come here and lock these screws back down. If you forget to do this, your star tracker is going to be very wobbly and you're not going to get good results. Alright, so once we have the star tracker properly aligned to the North Star, that's really the hardest and most important part of the process completed. So if you just have the normal star tracker here, you should have the brass screw installed. This is not the right screw for that. I'm going to be using the counterweight kit today. But if you do have that brass screw and you've got a relatively light DSLR with a relatively small lens, you can just screw your ball head in, attach your camera, and you're ready to go. But since we are going to be using a bigger lens tonight to photograph the Pleiades and the Orion Nebula, I'm going to have to add the counterweight. So before I do that, I need to go get the counterweight bar, install all that, and then I can add my ball head to the top of that and finish this whole process. Alright, I have the optional counterweight kit here. Again, if you want to see a very detailed way to do this, watch my other video. Today I'm just going to do it very quickly. But one takeaway I want to give you, if you haven't bought the Sky Tracker Pro yet, and you want to use a big lens or do deep space astrophotography, I don't know if I can honestly recommend it. This whole thing seems kind of like an afterthought, and it doesn't seem very well designed. Compared to the Sky Guider Pro from iOptron, that's much, much better. The whole counterweight system is actually very well done, and it's a great way to do deep space astrophotography with the counterweights and all that. This is mainly just kind of an entry-level star tracker that's good for wide-angle lenses or very light cameras. So if you haven't bought the counterweight kit, frankly, I kind of wish I didn't buy it just because it's a pain in the ass to use and it doesn't really work that well. Anyway, let's just get on with installing it. I'm going to just put it right through the center hole here, and then I'm going to grab the little lever that came with it and just lock this down. And just lock this down. Once that's nice and tight, now I can screw in my ball head. Again, this is the brass screw that originally came with the Sky Tracker. I'm just going to screw my ball head on there, and since I'm going to be facing west in this case, there's different ways, areas you can install this screw. You can either put it in the top here, which I've seen on iOptron's manual, but most of the time I've seen people just putting in this top hole, and that works well enough. Once that's nice and tight, I can loosen my ball head, get it set up for my camera, and that should be good for that. At this stage, everything should be set up. We just need to attach the camera and do a few other minor things. But since we did move things around a little bit when we added the counterweight kit and the ball head, I always like to go back, look through my polar scope, double check that my alignment's good. If not, remember again, the two main things are adjusting the latitude and adjusting these thumb screws to move the star tracker either left or right. So I'll go down. If I notice that the North Star is not exactly right as it would look in the app, I'm going to adjust for that. And then once I've got the North Star exactly where I need it, now I'm ready to go grab my camera, throw it up here, and I'll walk you through those steps next. Okay, so tonight I'm going to be using the Tamron 70-200 to get some deep space photos. So I'm just going to plop this right in here. And one thing I really like about this lens is that it's got an Arca Swiss plate built into the tripod collar. So I can very quickly and easily slide this in here, and I know I'm good to go. And at this point, I need to adjust the camera so it's facing whatever I'm photographing. In this case, we're looking south, and the Orion Nebula is going to be somewhere in the southern sky. So what I normally do is just loosen everything up, roughly align it, and if you've got a nice fast lens, f2.8 or better, I leave the camera turned off and I actually look through the lens, and then whatever you're photographing is bright enough, you should be able to see it relatively clearly. Once you've got it pinpointed where you need it, make sure you turn off the autofocus so it puts manual focus, and turn off any vibration control because you don't want that running. And at that point, we're ready to focus on the stars, set up our camera settings, and use our intervalometer. Okay, at this point we're going to focus on the stars. My preferred method is to turn the camera to the live view function, and you should have some plus and minus buttons somewhere on the back of your camera. If you do, you just zoom in all the way and go to your manual focus ring and just move it ever so slightly. Make sure you turn to infinity first, the stars are actually somewhat sharp, and you just turn the manual focus ring back and forth. You'll see the stars get bigger, smaller, bigger, and just try and get them as small as possible. Once you've gotten them focused, we can turn off live view. We don't want the sensor to heat up, and the sensor will heat up very rapidly on live view, so always turn it live view off if you're not using it. Next, we need to set our intervalometer, and that's really going to depend on our focal length and how long of a shutter speed we want. In this case, I managed to rig up a little bit of a homemade remote holder, because otherwise this would just be dangling in the air, and if there's any kind of breeze, that dangle will slightly jiggle the camera. If you're at 14 millimeters, it won't probably make a difference, but I'm going to be at 200, so I can't have any camera shake. So with the mirror, or rather the remote here, I can do a whole bunch of different settings. You want to consult your specific manual for that. Alternatively, I also have a wireless remote, and this is just infrared signal to my D750, and for that I can just click this once to take the photo, or if I'm doing bulb mode, I can click it once to start the exposure, time it manually. Once I've timed it, click it again, and that's probably the best way to have zero camera shake. But most of the time a wired remote will work just fine too, whatever you're more comfortable with. As far as camera settings go, again, it depends on your focal length. So my preferred method, let's say I'm using a 14mm lens, I can shoot for at least 4 minutes provided my star tracker is properly aligned, and get really sharp stars even at 4 minutes. So for that, I'll do 4 minutes, ISO 800 usually works pretty well, and aperture of f2.8. At that point, I'll make sure to turn the star tracker on, and again, if you have the wired remote, set the shutter speed and all that to 4 minutes, or if you've got the wireless remote, you're gonna click it once to start the exposure, time it on your phone. Once you hit 4 minutes, come over here again, click it. That will end the exposure. Once you've gotten to track stars, what I like to do, come on the back here, turn the star tracker off, so that way it's no longer tracking the stars. Take an identical exposure for the foreground, because we want to get a lot of detail in the foreground, and then we're ready to try another photo. All right, next I want to show you how to do this whole process with a zoom lens. But again, if you're just doing wide angle shots, all you need is a basic star tracker, and it's going to make your Milky Way photos so much better, because you can take that 4 minute exposure, if not longer, for the stars, turn the star tracker off, take 4 minutes for the foreground, and you can watch my other YouTube tutorial where I show you how to blend those two foreground and star scenes together very easily. And if you compare that side by side with your typical ISO 6400 20-second exposure, it's going to be night and day. You're not going to have to worry about grain. You won't have to do any more noise reduction. You won't have any kind of amp glow or anything to worry about. It's really an amazing difference. But if you're going to be doing deep sky stuff, our process is going to be a little bit more involved and quite a bit more complicated. So for that, there's a couple things you need to be aware of. First, does your camera have a built-in intervalometer? Second, how long are you going to be using your shutter speed for? If you're going to be doing 30 seconds or less, you don't need to buy a remote or anything. But if you're going to be doing 30 seconds plus, and you probably should be since you have the star tracker now, you're going to need either a wired intervalometer or, again, an infrared or Bluetooth remote that can connect to your camera. So you have to refer to your manual to see what you need. But a couple points on 30-second or less exposures. I'm using a Nikon D750, so I can go into my camera's menu. I can set the interval, so that's going to be how often it takes the photo, and that's really going to depend on my shutter speed. So if I'm at 200 millimeters, I think it'd be pretty good if I got 30-second exposures today. So if I set my camera to a 30-second shutter speed, my interval needs to be longer than 30 seconds. That way the camera has time to process the photo and save it to the SD card. If I don't give my camera enough time to process that, it's going to skip an interval, and I'm basically going to have a 20-second gap in between photos. So another important point I want to make, this might only be a glitch with Nikon cameras, but if you take a 30-second exposure, it's not actually 30 seconds, it's closer to 32 seconds. So be aware of that. If you're going to be shooting at 30 seconds, set your interval to about 33 seconds, and that should overcome that problem. Anyway, once you dial all that in, you kind of just sit back, turn it on, and the camera's going to start taking photos one after the other, and provide your star trackers aligned and turned on, it's actually going to move. Let's say we're looking at Orion right now, it's going to move at the same speed as Orion, so you don't even have to move the camera, and it's pretty much all taken care of for you. If you're going to be doing longer than 30 seconds though, it's going to be a little bit more complicated. So again, if you're going to be doing longer than 30 seconds, you're going to need to put the camera on bulb mode. So on my Nikon camera, that's just a shutter speed that I can select that's past 30 seconds. Some Canon cameras have that actually on the top dial. I think it's usually a B, so if you see a B, turn it to that. Again, consult your camera specific model to see how to turn on bulb mode. But once you have bulb mode, there's two different ways you can go about it. First is to, again, use the wireless or infrared remote and use your smartphone to time the exposure, or your watch. So if I was going to do 60-second exposures, I would click this once, at the same time click the timer on my phone, wait the 60 seconds, click the shutter button again. I know I've got one good exposure. I would zoom in, make sure the stars are sharp. If they're good, start another one, manually time it, and so on. And that's the way I used to do in the past. Then I bought the wired remote, which should make my life a heck of a lot easier. All I have to do is go into the menus, tell the camera how many exposures I want to take, and then tell it the shutter speed I want to use. Now again, if you use the camera's built-in intervalometer, you can only use 30-second exposures or less. With the external remote, I can do any time I want, whether it's 1 minute, 2 minutes, or 10 hours. So I pretty much just set it and forget it. But you do want to make sure you come out from time to time, stop it, make sure the stars are sharp. And it's not uncommon, if you're zoomed in, to get maybe a 60 to 75% success ratio. So even if everything's perfectly lined up, when you have the gears moving and the whole system just slowly rotating, there are going to be exposures that just simply aren't sharp. And that could also be wind. So don't be discouraged if you've got a few out of focus frames. It's probably just a combination of factors. As long as most of your exposures are sharp, you should be all right. There's just a few minor things I want to touch on before we end the video today. The first is, if you're going to be doing very long exposures, I would classify that as anything over 60 seconds. You're going to have to worry about hot pixels. Hot pixels are caused when the sensor heats up, mainly through using live view a lot and just taking very long exposures. And you're going to notice when you load your photos up in Photoshop or whatever you're using, brightly colored specks all over the photo. And they're very annoying to remove, especially if they're in the sky. they're going to be almost impossible to get rid of, and it's just going to look like a bunch of green, purple dots. Most people won't notice, but it is kind of a pain. My tip is to turn on long exposure noise reduction in the camera. When you do that, the camera's going to take the normal photo. As soon as it's done, it's going to take a secondary photo with the mirror down so that way no light reaches the sensor. Once it finishes that process, it's going to look at the two photos, find the hot pixels, remove them, and then save that as one final RAW or JPEG image. And that saves you a ton of processing work, and it's very easy to do. However, let's say we're photographing tonight and there's a lot of clouds blowing through and you have a very limited window where you can take your photos, and you don't have 4 minutes to sit around and wait for the camera to process. What you can do is take a dark frame. Ideally, you take your dark frame right after your normal photo with the same camera settings. You would just put the lens cap on, take the same exact photo, and that's essentially doing the long exposure noise reduction manually. And then you have to remove that in Photoshop or one of the stacking programs. I personally don't like doing that. It's kind of a pain to do, and the results are hit and miss. For me, long exposure noise reduction works a lot better. And frankly, you really shouldn't even have to bother with dark frames. It's just something, if it's very warm out at night and you remember it, turn it on. With all that in mind, I really don't like to do dark frames just because you're still gonna have to wait that same time that you would if you're doing long exposure noise reduction. You just have to do it all manually after the fact, and sometimes the results aren't great. So, you know, if you've got the time and you know your sensor's getting really hot, you can give it a shot. But for me, I'd rather just turn on long exposure noise reduction, wait that extra time, let the camera do its job, and it usually does a good job, and you're all set. Another thing that just popped in my mind, if you have a Sony camera, there's something called the Star Eater issue. If you haven't heard of that yet, basically Sony's internal noise reduction algorithms accidentally eat all the stars. Again, most people might not even notice it, but the Astro community has identified this months and months ago. They've contacted Sony. Sony's yet to do anything about it. So if you do have a Sony camera, make sure you look into that so you're at least aware of the problem, and hopefully Sony will release a fix, but as of now, they're kind of silent on that problem. Either way, your only real problem when you're doing long exposures, again, is going to be the hot pixels. I've got the hot pixel tutorial you can watch for more information on fixing that, but you're not going to have to worry about the noise anymore using the Star Tracker, and I think you're really going to be impressed by just how good your images look once you start doing exposures longer than 30 seconds. Okay guys, thanks for watching. Hopefully today you've understood how Star Trackers work and you feel a lot more comfortable if you've been thinking about getting one, or if you have one and you were still kind of confused why certain things weren't working properly. Again, if you do have the Ioptron SkyTracker Pro, be sure to check out my full-length tutorial on that where I cover every single piece in depth. Today we did go over it very quickly. If you want to do deep sky stuff, don't get the SkyTracker Pro. Look for something like the SkyGuider Pro or one of the other, like Star Adventure Skywatcher, I think it's called. Those are both built for that kind of thing. This is more for wide-angle shots and smaller cameras. And again, if you need to learn how to do the blending between the foregrounds and the stars, which you're going to be doing a lot more of now, I've got a YouTube tutorial on that. Finally, I've got a Star Tracker tutorial on my website. So if you're still thinking about buying one, you'll learn everything you need to know beforehand, including things like weight limit, the counterweight kits, how to align it, and so on. So that's about it for today. If you want to learn more about Milky Way photography, you can go over to my website. I've got a giant tutorial on that. And if you have any questions, feel free to leave a comment. If not, thanks for watching.